Hi, I'm Max. This is Max Makes Music, and this is Drezno by Xaoc Devices. And yes, you do pronounce that chaos in English and house in Cyrillic. I really hope I'm saying that right. Anyway, Drezno is the centerpiece of the so-called Leibniz Binary Subsystem, a family of Eurorack modules dedicated entirely to manipulating digital signals. Now, Drezno is a Eurorack format modular device, a type of music machine I'm really hoping to cover a lot of in the near future. So I know how scary it can be when you don't really understand this sort of thing, so I'm going to take it slow. For anybody that doesn't need an explanation of Eurorack, feel free to skip ahead to the jam or my explanation of Drezno in the description. For everybody else, I'm going to be giving a quick primer so everybody can enjoy the video. But now, let's make some music. Now, Eurorack, like anything technical, is much scarier at first glance than it actually is. Eurorack mostly refers to a size standard that all the modules, think of them as Lego pieces, should conform to. A simple way to measure the height and the width so that modules can fit together snugly in a case. You can't fit together Legos and Mega Blocks, though the difference here is that anyone can make Eurorack stuff, not just one particular company. Eurorack also means that all the devices will either use 5-volt or 12-volt power, and will all use 3.5mm jacks, the kind that you used to plug in headphones with before they started taking them off of phones and other devices, though these were stereo jacks and these cables are mono. They only have one ring instead of two. Beyond that, a Eurorack module could do pretty much anything. They can make sound, but they might not make sound. Lots of them don't. And that's part of what makes it such a wonderful medium for musical expression. Modular synthesis just means building sound in stages, and specialized devices called modules represent those stages. All things musical use this approach to creation in some way or another. They just might blend the steps together differently. In the modular world, we try to break those steps apart to allow us to mess with and mangle them, because it's fun. You really don't need a degree in anything in particular to have fun with modular synthesis. From here on in, I'm going to refer to modular and Eurorack interchangeably, though there are different formats of modules out there. Now, what usually scares people away from modular is the jacks and the cables and the big walls stuffed with blinking lights and all sorts of things. And it might be those big intimidating cases that are the worst of all. But here's a modular case. It's pretty small. It's actually one of the smaller ones they make. And it's really the same as one of those, exactly the same. You might think that there's something going on underneath here, but really, it's just a big power bar. And that's why there's all these cables and jacks and such. There really aren't any connections behind the scenes. We're in charge of all the connections between the modules. And that's exactly what we're doing when we're plugging one thing into another. They're the building blocks. And we're free to reorder them and mangle them as we please. Now, with that out of the way, we can talk about Drezno. It says here that it is a 1989 binary conversion computer, right on the top there. Though this isn't a complicated music thing, it's just a bit of Soviet styling that persists through all of the Xaoc Devices products. For something you can Google a bit more easily without getting confused for the city, Drezno is an ADC, an analog to digital converter combined with a DAC, a digital to analog converter. Simply put, it takes analog things, makes them digital, and then takes those digital things, or different digital things you might give it, and makes them analog again. Why do this? Well, that's what this video is all about, exploring why this is an interesting and musical thing to do. Here's the thing. You can't just listen to something that's been sampled into the digital space. Things that we hear from computers are converted by a DAC, and are used by our speakers to make waves in the air. I'll spare you an explanation of how sound works in our ears, but basically a speaker needs to move in a smooth, continuous pattern to ripple out air in ways we can hear, which requires an analog signal. Analog sound signals are just that, smooth, quickly repeating things. Now, digital signals aren't smooth at all. They are broken up by when they are sampled by a computer. An analog signal is sampled at discrete points in time, based on how fast the sampling rate is. In a computer, they're represented by quickly changing binary numbers composed of bits. Now, bits are like light switches. They're either 0 or 1, off or on. You can compare this to a light with a dimmer like this, something analog that smoothly goes from off to on to off. Now, you can't give a sequence of zeros and ones to a speaker and expect it to do anything. That's just not how they work. But this is where Drezno comes in. It can act as a middleman and make an audible signal out of these bits. And it just so happens to have the bonus ability to take an analog signal and convert it to bits before putting it right back. But Max, you might say, what is the point of something that just undoes exactly what it just did? That's probably the most unintuitive part of Drezno, and what I hope to show you here. A DAC's job is to do its best to make something out of the bits that it's given, but it can only work within its hardware limitations. Drezno only uses 8 bits at most to represent digital signals, meaning that even with nothing else plugged in, you're going to get a subtle audible effect out of anything you feed into it. This is due to something called quantization noise, giving this crunchy, harsh-sounding distortion. Now, here's an example of a sound without Drezno. And I'll start introducing Drezno. And then all the way, only hearing what's coming out of the DAC. Now, it's time for the modular part of Drezno, the inputs and outputs, which I've labeled for you here. Now, most stuff in Eurorack works like reading English. You prefer to read things from left to right, inputs to outputs, etc. Drezno is labeled a bit backwards. Now, due to its nature as a conversion platform, I'm going to tackle it in halves. Signals into the ADC half on the left create 8 bits, which come out of here. These 8 bits are also represented here with these yellow LEDs. Either they are off for 0 or on for 1. Now, these bits are actually either 0 volts or 5 volts, letting you plug these outputs into any other module that takes these very common and useful values. Now, depending on what you give it as an input, the patterns of bits output here can prove very useful with a little bit of imagination, something we'll go over in depth later on. Now, let's move on to the right half, Drezno's built-in DAC. With this link engaged, the bits it's being given will come from the left half, but using these 8 inputs right here, you can forcibly override those bits. Like with the left half, your bits should either be 0 or 5 volts, but they could come from anywhere at all. Some neat ideas for this are clock sources, logic modules, and even the same bits from the left half, but reordered in different ways. The bits on Drezno are ordered from most significant bits at the top to the least significant at the bottom. If you were to mess with the top bits, they will actually have a much bigger impact on the output waveform than the bottom ones. If you were to use an inverter to flip the top bit, you'll actually flip the entire signal about the x-axis, which will completely change your output waveform. Ultimately, it's all about distorting whatever it is you're putting into it in weird ways that the human brain isn't so great at thinking about. But that's why Drezno is a computer, and that's why we like it. In the middle, you can see there are 4 LED faders labeled gain, offset, offset, and gain, which allow you to adjust the inputs and outputs of the ADC and the DAC respectively. Now, using the offset, you can actually provide Drezno with bipolar signals instead of the unipolar ones it expects, and you can actually get out bipolar signals instead of the unipolar ones it outputs by default. You can also sample using your own clock to the ADC or the DAC, though Drezno has its own internal 2 MHz clock, which allows you to sample any audio without any concern about aliasing your signal. I've already shown that Drezno can apply an audible effect to a sound. However, Xaoc Devices has always intended on it being much more capable than a simple effect. As I said, by default, Drezno will perform analog to digital conversion using 8 bits. But by feeding it zeros to any of the bits on the right and making sure the link is enabled, Drezno will only convert any of the remaining bits back to analog. Now, this will create something of a bit reduction effect on the output. If you take a patch cable and leave one of the ends unplugged, it's pretty much the same as feeding it zeros. So if I begin to patch bits, you can hear the bit reduction effect getting more pronounced as we go from less significant to more significant bits. Repeating signals, like LFOs or just plain old oscillators, will produce predictable, rhythmically synced patterns of gates. In that way, it can be used as a rhythm generator to feed other modules such as drums or VCAs or anything that accepts gates or triggers. If I remove the audio source from the ADC input and replace it with this LFO, we can see on the LEDs that we have a rhythmic output of bits that we can use to patch something like this Erica Synth's sample drum. And if you notice, the lower down, the less significant of a bit that we patch into the trigger, the quicker the repetitions are. That's because the less significant bits have to flip a whole lot faster than the more significant bits. And you can really get some interesting patterns out of something so wild. But it's still within your control, which is really neat. What's also very interesting to consider is what else you could feed the right half of Drezno in place of constant bits. There's a whole family of modules which would pair perfectly with Drezno's digital nature, Boolean logic gates. You could produce a completely different sound by feeding the output bits on the left to different logic gates and then feeding them back in on the right. You can even accomplish something similar by cross-patching the bits, leading to a whole world of experimental distortion options to play around with. But what I think is much more interesting is what the rest of the Leibniz Binary Subsystem can bring to Drezno, specifically Xaoc Devices Jena, the latest in the line. Now, I'm going to have an entire extensive video dedicated to Jena, but just as a preview, it takes the concept of tables and transfer functions and uses them to greatly expand Drezno's digital capabilities. But enough talk. I've put together a little patch demonstrating Drezno's rhythmic capabilities, its modulation potential, and just how fun and enjoyable it is to experiment with and play with as a standalone module. I hope you enjoy it. So, I hope you enjoyed the jam, and I hope it showed off at least a few of Drezno's many capabilities as a rhythm generator, an effect module, as a source of chaos to add to your patches. Now, admittedly, I still don't fully understand where I'd classify it in the grand scheme of modules, but I know for sure that it has a sense of inherent musicality, even if it's not so intuitive. Now, as a simple effects module, I'd say that there's quite a few other options out there that take up less space and might be less expensive and complicated than Drezno. But as a gateway to an extremely powerful way of thinking and patching, Drezno has to be given commendations in spades. Many modern effect platforms use digital signal processing as a means of accomplishing a whole lot with very, very small chips and boards. Now, sort of like how modules seek to break up the sound creation process, Drezno seems to want to break up the digital signal processing process by exposing the fundamental building blocks, the bits, to the user for manipulation. And what's nice about it is that digital logic can be manipulated by very simple and very complex modules in a ton of ways, allowing for infinite possibilities. Additionally, digital logic is pretty simple to get to grips with. It doesn't take all that long to learn how Boolean logic works, and it opens up a whole lot of opportunities for you. And it's all possible thanks to this. Now, Xaoc Devices clearly understands the amazing things that can be done in the digital domain, and I think it's very smart of them to start their system, the Leibniz Binary Subsystem, by exposing those fundamental building blocks to the user to get them accustomed to them. And really, I hope that Drezno can give people a better appreciation for the simple power of bits in Eurorack. Oh, and by the way, just a little tip, if your Drezno happened to come with the expansion cable disconnected from the module, you'll have to plug it in to the expansion headers at the back. Make sure to plug in one side to the in and one side to the out, and neither of those sides to the power connector, as that'll void the warranty. Without doing that, Drezno actually can't access its own 2 MHz clock, which means that nothing will come out of the DAC output unless you give it its own clock. Now, that certainly confused me when I first plugged it in, as I thought mine was broken, but it certainly isn't. It's just a little strange. So I hope you can enjoy this cursory look into the realm of digital signals. It's a field that I have particular reverence for, as I have a bit of a background in it, and yet I can't quite say that I have a full grasp of its real power, but I can certainly tell you that it's capable of amazing things. Now, the guys at Xaoc Devices clearly understand that too, as they've made some really wonderful additions to the Eurorack field with the Leibniz Binary Subsystem. I'll definitely be taking a look at the other members of the family, Lipsk and Jena, in due time, and I'll be happy to explain even more about digital signals to the best of my ability. So if you enjoyed the video, please like, comment, subscribe. Anything is appreciated, everything helps. I hope I could explain what I think is a bit of an unintuitive but amazingly powerful module to you, and I hope to do more things like this in the future. So, once again, I'm Max, and I hope I helped you make something.